Hello, this is the second video about SimPars, and in this video we will demonstrate how the SimPars could be used for transformation of the Simulink models which contain state charts. The model is prepared, the blocks are marked, and we can run to ErrorPro script. So we are running it with the parameter GCS getCurrentSystem, and it starts creating first the control flow between the output functions of the block, including the output function of the state charts. However, it also analyzes how the states of this state machine changes and creates the separate control flow between these states. Second step is the same, we are connecting the data flow. The third step is also the same, we are generating the conditions for all the blocks, including the state chart. However, for this state chart we cannot afford to analyze all the combinations of errors in these 6 inputs, because 2 to power of the 6 is a rather big number and it will take a very long time. That's why we are doing a small trick here. We are just analyzing the propagation of the error from first input to these 2 outputs, then from second input, and so on. We do not take into account if, for example, we have errors on both inputs. So we are just analyzing all the inputs separately. The results are a little bit less precise, however, we can get them in the, let's say, in the finite time. Okay, and the last step, we are generating the error propagation model, and we are generating the levels for each state. Let's load this model and I will explain it with the model. Okay, if we open this model in the ErrorPro, you can see that model is too big, we cannot draw it because it has a lot of elements. Let's check it and let's switch to the nested view. And on the top level you can see 7 states. These 7 states was generated from the states of this state chart. You can see that the state chart is rather complex. It has 2 top-level states and then 3 states inside the second state. And this 7 state, it is basically the combination of different states of this state machine. For example, we are in a second state and the second substate of the second state. So we also should take into account that the states in the state charts, they have entry, during, and exit sections. And these sections we also took into account and generate the separate states for them. And inside each state we have preliminary the same error propagation model. The difference is actually on this block which was shown, because this block shows the probabilities of error propagation through the state chart function. So let's perform the computation, and the computation was rather long. I've speeded it up and we switched to the region of interest view, and you can see that inside each state we have different number of errors. But if we take a sum, for example, of this number of state and if we will sum up the number of errors in the blocks of each state, we will get these numbers. That's how the SimPars and ErrorPro works with models with states. Basically, we are creating this separate error propagation model for each state, and we are generating the conditions how all these blocks working when the state machine is in this state or in that state. This approach shows rather precise results, and this is how SimPars analyzes the Simulink models which have state charts. If there are a number of state charts, we generate these sub-models for all combinations of states of the state charts. Thanks for watching.